Hey friends, welcome to another episode of What's New in Prisma version 4.9.0. I'll be your host and my name is Alex. Today I'm joined by my two colleagues, Tasin and Tyler. How are you?
Good. How are you?
I'm doing good. How are you, Tasin?
I'm great as well.
Awesome. So today we have a pretty packed schedule for you. We'll start over by going through the release notes. And then after that, we'll have Tyler, who's from one of the engineering teams, talk about the product we released about 2 weeks or 1.5 weeks ago, or, called Accelerate. And then after that, we have another guest called Vasek, and he'll talk about the Prisma Playground that we launched in December, right before Christmas. And then after that, we'll have our final guest, Rida, who will talk about Schemix. And if you have any questions, feel free to post them throughout the stream. We'll pick them up as we continue with the stream. So let's get started. I'll go ahead and share my screen for the release notes. Let me know if you can see it and if it's the right size.
It looks good
Cool.
for me.
Cool. Thank you. So last week we released a couple of new preview features and a couple of fixes. And the first one is database views. It's the initial support, meaning that it doesn't work perfectly, but it works. I know it's a weird, confusing state. I mean, by it works, you can define a view in your Prisma schema using the view keyword. However, the part that doesn't quite work yet is the migrations part that you have to do yourself. But when you generate Prisma client, you'll be able to query your views directly from Prisma client. The other preview feature that we also launched last week was multi-schema support for SQL Server. So this means that you can introspect your database if you're already using multiple schemas. You can generate migrations and you can query across different database schemas. And the important thing to note is that you have to define the schemas that you want to be introspected or want to work with in the data source block, and then run Prisma Migrate to generate a migration, or if you already have schemas, you'll have to run Prisma DB pool. We also made a couple of improvements to the Prisma client extensions, like being able to retrieve the current model name when Prisma client is being executed, and improving the type safety when defining custom model methods. A few other improvements. The other one is the introspection and migrate engine improvements. Previously, one would have three separate engines. So there would be the query engine used by Prisma Client, there's the introspection, which is used by DB Pull, and the migration engine used by Prisma Migrate. So in this release, we moved the introspection engine into the migration engine. So meaning you only now have to deal with two engines. So the Prisma Client engine and the Prisma Migrate engine. The next improvement that we also shipped was the write conflict fix for MongoDB. I know this has been an issue for a lot of people for the last couple of releases. We went ahead and fixed it. So try it out and let us know what you think. And finally, thanks to the team over at JetBrains, they released an official integration for Prisma for any of the JetBrains IDEs. So if you're using a JetBrains IDE, feel free to install the plugin, try it out, let us know what you think and how it goes. We will also talk about Accelerate in the next segment, and that is all for the release. We have a couple of fixes and improvements. In case there's anything that doesn't work as expected, please let us know so that we can fix it for you. Yeah, and from now we'll move on to the next segment where we'll have Tyler, and he'll talk to us about Accelerate that we released 2 weeks ago. Yeah.
Yeah, thanks, Alex. I'm excited to talk about it. So yeah, Prisma recently announced a new product as part of Prisma Data Platform. We're calling it Accelerate. It's all about enabling Prisma users to build faster, more reliable applications that scale better reduce database load, and improve the latency of their applications without having to manage infrastructure or getting into the complexities of that. It can improve the performance of a lot of different apps, we think. We're seeing really good results, but serverless apps in particular, I think, have a really nice benefit from partnering with Accelerate.
Yeah.
So yeah, it
I
operates.
also think that, sorry for interrupting. I
Go
also
ahead,
think
go ahead.
besides serverless apps, I think edge specific apps, edge applications would also benefit because your data is already cached in 208 locations. So your database, your queries don't have to make the one long request to your database. So you can just go to your nearest edge location. Yeah.
Exactly. Like that geographic distribution can benefit a lot from Accelerate's infrastructure. So it operates as a globally distributed delivery network. It's kind of like a CDN for your data. I can get into some of the details of that in a bit. That part is built on Cloudflare, which has about 280 POPs that we're able to work with to distribute that data all over the world. So your applications are likely running very close to a Cloudflare data center. That latency is going to be very quick. It also provides a serverless connection pool out of the box. So switching on Accelerate gives you a centralized connection pool. So as your serverless apps are spinning up and down, you're able to reuse database connections in our backend. And we can move that connection pool close to where your database lives so that you're not making these cross-region calls to get data. We're able to sort of compact that into a smaller request, send that all the way back to where your connection pool lives, and then make the multiple round trips to the database to aggregate that data together, and then ship it back in one response. So we can really improve that efficiency across that cross-region boundary. So this
Tyler,
yeah,
sorry. So just to kind of understand a bit better. So like, let's say I'm a user who's running an application and decides to use Accelerate for, let's say I'm running a serverless app, like maybe a Next.js app. So what would be the value of using Accelerate for me, like as an application developer?
Yeah, absolutely. Maybe it'd be helpful to demonstrate a little bit of that and sketch it out. So I'll share my screen really quick. Let me know if you can see this okay.
Oops. Yeah.
Cool. Yeah, I'll run a quick maybe sketch here in Excalidraw. So let's say you got the world. This is my representation of the world. And you got that serverless app you talked about, Tasin, kind of distributed in all these different places. These are your serverless apps. Just going to copy that over here so be lazy a little bit. And right now you have your database running likely in one location. So this is your database. And all of these nodes are talking to your database. Some of these have longer errors than others because they're all over the world. You're deploying that app in Vercel. You're deploying it maybe in their serverless functions or edge functions, either way. That's going to geographic distribution. And you've moved your application code really close to your user, which is great for their latency, but you're still making these really long calls back to your database. So this is where Accelerate comes in. If we move this just for convenience sake here, get rid of some of these arrows. We'll put Accelerate sort of in the middle here. If we grab the arrow. So Accelerate sort of lives in the middle with all of those POPs that we mentioned and moves the right or the different types of work to the correct side of that regional gap. We can't get rid of the regional difference, like we can't bend space and time, but we can at least move the right pieces of work to the right side and make it as seamless as possible. And what that means is moving those edge POPs really close to your serverless apps and your connection pool close to your database, and being able to reuse those connections across those serverless instances. So does that answer your question, Tasin? That sort of is where I see the biggest benefit of accelerating these serverless apps. And then we'll get into some of the caching things next.
Yeah, so what I understand is that if I have an application that's geographically distributed all over the world, I can get to the server very quickly from wherever I'm located. But that server still, well, it could be serverless, but it's still some kind of physical computer server somewhere. That server is still kind of slow to talk to a database if that database exists like in a totally different location.
Exactly.
So what Accelerate is doing, it's running all these nodes or POPs very close to our uh, web servers, and that helps us elevate issues with latency. And also, as you mentioned, some other things like with connection pooling, like reusing the database connections and so forth. But primarily, I'm able to reduce the latency to like fetch data from the database using Accelerate.
Exactly. And then we take that one step further with Accelerate by adding caching in on this. And this is something that I'm really excited about. I think this is a huge improvement opportunity on the current sort of state of things. So we have these pops out here that these serverless apps are talking to, right? And we have the connection pool that we moved back close to the database, but we had those long lines still going across region. But with Accelerate, we've enabled caching on all of these pops. So we use Prisma Client extensions. Prisma Client extensions open up all sorts of cool opportunities. We keep finding new ways to leverage them every day. And one of the ways that we're leveraging them for Accelerate is to add on an additional argument to all of your Prisma query operations. So your find first, find many, aggregates, counts, those types of operations, get a new cache strategy field added by the Accelerate extension. And in that, you can specify a TTL install while revalidate that signal to Accelerate how long you're willing to cache that data for at the edge. Now, what happens is your application using Prisma Client sends that signal to Accelerate with those cache strategies. And in this case, maybe we have a fresh cache. We completely eliminate that database call. And the cache data is served from that edge node and never touches your database. Not only does that improve the response time, it reduces your database load because now like that expensive operation you were running doesn't even have to run on the database anymore. In some cases, you might want to still get a cached result, but refresh the data in the background. So you get sort of the best of both. We call that, or that's called cell while revalidate. We use that in the cache strategy, and you can signal how long you would like to leverage that. In that case, this line becomes more of like a dotted line. We still serve the data from the cache very quickly. And in the background, Accelerate will go back to your database and run the query and then update the cache with the new value. So the next time your client makes a request, you'll get that updated value. That unlocks a lot of cool scenarios of you have an expensive operation, you want to keep it relatively up to date, but maybe you're okay with it being slightly delayed. You can leverage cell while revalidate to get that. And then for things that don't use a cache or cache misses, we'll still go back to your database and fetch the data. If you specified a cache strategy, we'll populate that cache on the way back out. So the next time you run the query, you'll get a cache hit.
Oh, nice. So as a front-end developer, when I'm listening about Accelerate, it kind of sounds like React TanStack query and use SWR, but for the database. Is that a fair analogy to make?
I think that works. Yeah. We try to make things pretty seamless. We do give you those levers to pull. We don't do we don't sort of try to make inferences about how you'd want to cache your data. Every scenario is unique. But we do give you the options to specify that. And I think that's really valuable because we found that even the same query executed from multiple different code paths could have different tolerances for cache. So for example, maybe you're building an app that has a message feature and you have like a notification count throughout your app. Maybe the one in the nav bar, that can be a little bit stale. And maybe it's expensive to sort of go back and compute that count. You want it to be really fast.
Yeah.
So that unread count in the nav bar, you could use stale while revalidate to keep it sort of fresh, but also serving from cache really quickly. But then when you go into your messages like page, maybe you want that count there to be up to date and accurate because you're showing the messages. It would look kind of strange if the count was different than the number that were unread. So those two queries might be the same, but they have different cache strategies to them. So we really try to give you that flexibility to define it at the query level.
Nice, nice. And is there any particular reason we went with Cloudflare over, I'm not sure of other solutions that are available in the space for Accelerate?
Yeah, that's a good question. We evaluated some options, and Cloudflare definitely stands out as having this like really global network. They have a really powerful cache system we can work with to move all this stuff as close to the application as we can. and they have a really robust infrastructure and powerful backend. So even without caching, this backend request going across region is very stable because it's built on Cloudflare's backbone. So we don't have to maybe think about some of the, I guess, latency concerns of where that request is going. It's routing through Cloudflare's backbone. That's really stable and secure. They do a lot to optimize that. So partnering with them enables us to really focus on the caching aspects and bring along all the research they've done in networking.
Pretty cool. Pretty cool. And I believe you have a demo for us, right?
I do. Yeah, and I'm excited to show this. So we built this demo speed test application. We plan to open source this very soon so that people can use this as maybe an example of what Accelerate can do. So when I run this speed test, it'll run for about 5 or 6 seconds. And this is running on a Vercel edge deployed edge API route test run. It runs as many sequential requests as it can with cache and without cache. And it sort of counts those up and times them and reports the P50 results of that. So essentially with the cache, we see, and the query it's running is a fairly simple count operation. We do have like 500,000 records in this database. So it's not even like too crazy. It's tracking like number of times the link's been opened. And we're looking for things where the user that opened the link, their email contains .com. So it's not a super complex query, but it is a pretty expensive one for the database to try to compute. There's a couple of joins in there. There's some string matching. It ends up putting a decent load on the database. What we see is pretty consistently on the with Accelerate caching side, it'll sit between like 17, 20 milliseconds typically for me. It can vary very slightly by region, but it's fairly consistent at that 20 millisecond. And that's a round trip to that POP and back from within your serverless app.
Those numbers are strikingly different, like
Yes.
17 and 1570.
Yeah.
I do want to ask just to clarify a few things. So you're saying this is the P50 value, and as I understand it, that's like the median value, right? It's the value, the median or the most, like 50% of the requests are being served with Accelerate within 17 milliseconds and without Accelerate in like a second and a half.
Exactly. And we could probably expand on these stats some more in this application, but what you'll see if you look at the overall distribution, even behind the scenes, Accelerate is pretty flat. It tends to come back in this like really quick timeline. Without Accelerate, varies all over the place. These numbers are pretty wildly, because they depend a lot on the database load. They depend on the network load going across region back to the database. Lots of networking factors there that come into play. Like how many hops did it have to take to get back to the database? And yeah, we see these pretty startling differences. If I run it again, we'll probably see a very different result on the without Accelerate. That time also varies drastically based on your region. So you guys are in Berlin. If you run it, you will probably see a different result than me because this database lives in US East.
I see.
So that's where we see a huge benefit.
So as I kind of understand it, the reason that Accelerate is so consistent is because it's just consistently talking to what you're calling a POP, which is essentially a POP or a data center, right? That's very close to where the client is running or where this web app is running for you, like the end user.
Exactly.
But without Accelerate, the database could be in like a very, very different region, and communicating that over like just the internet, it can be unreliable, and the milliseconds needed can vary quite a bit. Is my understanding correct?
Yes, that's exactly right. And like I said, you'll see that in the results as you run it from different regions and measure things there. Now, as far as like enabling this, I can show how the code is set up to get there. Like I said, we plan to open source this so people can take a look.
Maybe you could zoom in a little bit.
Yeah, sure.
It's a bit hard for us to see.
Is that better?
Yeah.
A little bit more, maybe. Yeah, much better.
Awesome. So yeah, to enable Accelerate, first we use client extensions, like I said. So you do need to enable the client extensions preview feature in your schema file. You run a new Prisma generate for that. You will run Prisma generate with the data proxy argument added. That sets up this sort of query engine to talk with Accelerate for early access. And then when you instantiate your Prisma client, you can use the extends function that's enabled by the client extensions feature. And we have this Prisma extension accelerate package that you install. This is the actual extension code for accelerate. You just register that on your Prisma client, and that will actually augment the type definitions of all of your find functions on the Prisma client. And it will add this new optional cache strategy. So you get type safety on this new argument while still using your Prisma client as you do today. It's completely backwards compatible. You install it, you extend it, all of your existing operations just start funneling through accelerate. And you can start incrementally adopting cache strategy where you'd like to.
So what you're saying is like Accelerate is completely a standalone extension, and it's not really baked into the Prisma client itself. It's just using the Prisma client extension mechanism to build on this additional kind of feature or service on top of the like base Prisma client.
Right. And that's where I think it's so powerful with client extensions. We're able to do all of this just by hooking into some of the APIs that client extensions give us. And then
yeah, that's amazing.
Yeah. And then running the actual operation, it's as simple as adding this cache strategy. So you see here, we actually run the same Prisma operation and just conditionally add in a cache strategy. It's as simple as that. We use TTL here to specify that we want to just keep that data in the cache for a long time. You can also specify stale while revalidate here. Our docs will get into a lot of details about when you might want to use each and how to combine them together to have a really good experience. But it's all up to your use case, like how tolerant are you of different cache values, and when do you want to refetch from your database and push that load back to your database.
And so TTL is what exactly, if you could just summarize it for us?
So that's your time to live. That's how long the data can live in the cache. It will just serve from the cache. So back to our diagram over here, maybe. That's this example that doesn't go back to the database at all. So if you say the TTL is 60, that means 60 seconds this data can live in the cache and serve from the cache without ever touching a database. Stale while revalidate, that's abbreviated SWR in our API. That one signals, if you say that's 60 seconds there too, then for 60 seconds, you'll serve the data from the cache, but any request that comes in will always go back to the database and refetch data and update the cache. But it does that in a non-blocking outside of the request context so that your app still gets a really fast response, and accelerates backend handles that slow load back to the database and refetching the cache.
I see. So it's so with stale while revalidate, it's going to give you data from the cache, but it's also on the side going to update the cache so that future requests have like the updated, like does not have the stale data anymore. Is that correct?
That's right.
Okay.
And you can stack those too. So you can say, I want a TTL of 60 seconds and I want a SWR of 360 seconds. And that can, combining those can reduce the load on your database, but still refetch things in the background for some time period before you consider, I just want to go back to my database and get new data. So you can really combine those two things and move the levers to fit the use case that you have and how tolerant your data is to being a little bit stale. And yeah, you can even set the TTL to 0 and then have an SWR value and get that like sort of like N-1 type of data loading where I'm always like one request behind being fresh, which is pretty powerful.
Interesting.
Super interesting. So how can, again, assuming that, let's say I'm a developer and I want to consider using Accelerate, like what do I do? How do I go about and like enable this feature, or what can I do to get access to this?
Yeah, so Accelerate's in early access. If you go to prisma.io, you'll see our announcement posts and some additional information. There's a join waitlist there. So anyone that's listening, you can go join the waitlist and we'll contact you when we're ready to bring you into the program. You'll be able to try it out. We'll share documentation with you. We'll help you get set up with your Accelerate connection string. And you'll be able to try it out, play around with it. It's free to use in early access, while we just want feedback. We want to know how people like it, how they want to use it. And yeah, we hope to target a GA release mid-2023. We were really excited for that. But yeah, check out Prisma.io, check out the the page there about Accelerate. Check out the blog post by Andrew. He's got some good stats there too. And reach out.
Yeah, so for anyone interested, you can use this link, prisma.io/accelerate, to join the waitlist and consider like giving Accelerate a try.
Awesome.
And this is what it looks like.
Yeah, very cool.
All right.
Well,
Thank you, Tyler, for joining us. It was really nice having you, and it was really nice getting to know more about Accelerate. It just seems like a really interesting and like really, really interesting feature.
Yeah, thanks for having me. I enjoyed the time talking about it.
awesome. Thank you for joining us. We'll see you on Slack.
Yep.
And talk to you later. Yeah.
Cool. Hi, everyone.
Cool. By the way, Tasin, have you tried out Accelerate on your own?
I have actually. I was going to, but I have not joined the waitlist yet, so I don't have permission. I've been looking at the docs, and I have to go ask someone from the relevant teams to give me access. But I'm thinking of doing that today or tomorrow. So just a bit of a technical difficulty.
I know we are acting blind, but actually you can already try it out because we are at Prisma anyway. I did try it out last week with one of our internal tools that we built in our team by Sabin, actually, for some analytics.
Oh, okay.
There was some improvements in terms of the query performance. I saw those it was mostly aggregate queries because it's a dashboard, and some of the queries were trimmed down from about 350 milliseconds to, I don't know, 20, but it's probably already, the queries were already fast because the database is hosted on PlanetScale. I'm not sure if there's anything special PlanetScale is doing as well, but still some improvement, and hopefully we can dog food Accelerate with our own tools as well. Yeah.
Yeah, and what I thought was really cool is that you can set these the caching strategy at a query level. So for example, there might be some queries like, for example, let's say you have a dashboard or some kind of leaderboard, or you want to show some kind of metrics. Those kinds of things, maybe they don't need to be like updated to the most like it's okay for the data to be stale. So there you can like for those queries you can like cache it and have like really performant queries. But then again, you might have another use case where you need the data to be like the most recent value in the database for whatever reason, like let's say a financial transaction or whatever. And there for those queries you can also use the appropriate like right set of like parameters as well. So that's a really powerful tool in my opinion, like having that flexibility.
It is indeed. Cool. And now we'll move on to our next segment where we'll bring one of our guests, Vasek, to talk about the Prisma Playground.
All right.
Add him to the stream.
Oh, hi.
Hi, Vasek.
Hello,
How are you?
Hi, I'm great. Thanks for having me today.
Well, it's a pleasure to have you two on the show as well. So for folks that do not know you, because since this is your first time on the stream, could you introduce yourself?
Sure. So yeah, I'm Vasek. I'm co-founder of a startup called Devbook, and you might more know us as a Prisma Playground currently, which is what we are here today to discuss. And with Devbook, our goal is basically to make it easy or easier for developers to learn and try out the tools and APIs they are using every day. And from the point of the companies, it is to make it easier for them to onboard new users and educate them about their products and the tools that they are building.
Nice. And was there, like, what motivated you to build Devbook? Was there like a painful experience that you tried out with a product that just drove you down this path, or
Oh yeah.
yeah?
I'm myself. I'm a developer. My co-founder also is a developer,
Mm-hmm.
and I I get kind of like angry when I can't figure out how to use the tool. So I'm just trying to cure my frustration with the world, and yeah, basically I always thought that it should be much easier to try out developer tools, especially since we are trying them on our we are learning about them on our computers, and I thought that the whole experience could be much more interactive, and much more like hands-on experience, basically like
Yeah.
show don't tell.
Okay. Cool. Cool. That's as I'm not sure. I don't think it's his name, but it's probably the name of his channel. But Business of Technology, likes your passion. It's also his passion as well, by the way. Just to show you.
Ah, nice. That I'm happy that I'm not alone in this world.
Yeah. Yeah. And could you? Are you ready to share your screen? And
Yep.
well, we can talk about the Prisma Playground, or it's a product of Devbook. Yes.
Yep. So with Prisma, we collaborated together to build something that's called Prisma Playground, and it's a great way to try out Prisma without needing to set up anything, and you can try it out right in the browser. So we always thought that Prisma is really great, really useful tool that makes developers much more productive. But one of the kind of like blockers during the learning about Prisma is, for example, you need a database, and you need data in the database. You need to connect Prisma to the database, and all these other things that kind of take your focus away. And so in the Prisma Playground, there are two sections where you can learn more about Prisma. The first one is Prisma Client, which is kind of like this coding playground with live examples, where you can try out Prisma SDK, and you can try it out against a running database that's running for you on the background. So here are all kinds of queries that you can do with Prisma SDK. It's great to explore the SDK. You get all the benefits that you would get if you installed Prisma extension in your Visual Studio Code coding environment, for example. And when you run the example, it actually returns the result from the database. And these are the data that lives in the Postgres database that's running for me right now in this session.
Nice.
The second section is Prisma Migrate, and these are a completely different experience. Again, it's an interactive way to try out Prisma, and specifically to learn about how you can use Prisma Migrate command from Prisma CLI and Prisma Migrate workflow to do a certain operations on your database, like creating a column in your table, deleting an enum, creating a different relation, like one too many, many too many. And I will just open quickly one guide. And these guides are basically like tutorials that show you how to do that specific workflow and operation. And they, again, do it against a live database with an actual code, actual data, and you can run everything right in your browser to learn how that workflow works. So on the left side, I have a coding editor with a Prisma schema. On the right side, I have the instructions. And for example, here I'm supposed to add a likes field to the post model. and then I get full terminal, which is basically like full computer. There are the files that are actually live in the project on the background, and now I can do the migration that actually creates a new column in my table, which takes a while. So this is the basic idea that how you can learn about the different workflows in Prisma, and how to do very specific things.
Nice, nice. And if you don't mind sharing, what are some of the tools or the infrastructure that you use to build the interactive playground? Because I'm sure it doesn't really run on the browser, does it?
Yeah. So what we actually do is that every time a user visits Playground, they get assigned a full VM. It's a small VM, but still, I realize it's a VM. It's actually running on a technology called Firecracker. So we start these VMs in a few hundred milliseconds, and for example, in the Prisma use case, this VM has a running Postgres database, and it has all the code prepared by Prisma. So every user gets basically it's like giving every user a computer that Prisma prepared for them, and then instructing them what they should do with the computer to learn more about Prisma SDK and CLI.
Cool. I believe Firecracker is also the same technology that powers Fly.io, I think.
Yeah,
and
it's
Code
been getting pretty
Sandbox. Yeah.
popular. So it came from AWS, really awesome project. And originally, AWS Lambda, like their serverless functions, were built on top of it, and I think they still are. And other tools is other products is Fly.io, and specifically their machines, which is like serverless servers. And recently, Code Sandbox have also migrated to Firecracker. It's a really awesome tool, especially since you can do something that's called snapshotting. So that means that you can create a whole environment. You can start all kinds of processes. For example, the database, you can start it, it's running, you can start a server, and then you kind of like save it, which is the snapshot. You make a snapshot, and you save it at that moment with running processes, and then you start it in a few milliseconds, and all the processes are running again.
Cool.
Is
And
that
how
what
fast?
Devbook is doing?
Yes,
Sorry,
exactly. Yeah.
It's all good.
Okay.
Cool.
Yeah,
And
sorry
how
to
long does
interrupt
it
you, Albert.
actually? It's all good. How long does it take to actually provision, I guess, one snapshot for a user?
Yeah, so I think we are currently about like 150 milliseconds or like 200 milliseconds. So we should be able to go as low as like 50 milliseconds. Or I've seen examples doing that, but for development purposes, we think 150 it's good for now.
Yeah, it's amazing.
It is. I think it's probably developers who have high expectations that anything above 20 milliseconds is too slow. I don't know. It's just my opinion, but I'm sure it's not all developers.
I agree.
Cool. I think, and on the front end, are there any particular technologies that you use? And actually, how do you sync whatever the user does on the web with whatever's, I guess, in the provision VM?
So on the front end, it's pretty boring stack, but like stack that works. So we are using Vercel, Next.js, and of course React, and I'm thinking, yeah, and the guides itself, like from the point of view of the creator, they are written in Markdown or MDX, and the code, the client example, the coding sandbox example, those are just like regular coding files that you can run, test, and we just load them during build time to the Next.js app. And in terms of synchronization, So we are using WebSockets. We basically wrote our custom layer on top of these Firecracker, these VMs that are running on our backend. So we have like special process running in every VM for each user, and this process communicates with your browser through WebSockets. So the communications is bidirectional, which is great way to enable like real timeness.
Nice, pretty cool, pretty cool. Do you have any questions, Tazeen?
No, I think you actually asked the questions kind of I was hoping to ask, like how does it work? But yeah, I think it's all good on my end. And yeah, it's a really cool like experience. I think I was playing around with Playground, and for the first time I tried it, it was like, wow, this is just very seamless.
Yeah, and also, sorry to interrupt. Go ahead.
I just wanted to say, like, really happy that you like it.
Yeah, of course.
Cool. And I would also like to highlight that the difference between, for example, using StatBlitz and I guess the Prisma Playground is that you always have like an editor on the side, and I don't know what to call that component with the instructions. That's always there, or that's the only part that kind of changes as you transition from one section to another, that makes the whole flow while you're editing stuff or trying something out kind of seamless. Yeah. Yeah. Cool.
Yeah.
That's about it from our side. Thank you, Vasek, for joining us.
Thank you.
If people would like to reach you, how can they reach you, by the way?
So either on Twitter, or you can go to our landing page, use devbook.com. We are currently in private like beta. There you can contact us through form, schedule a call with us, and we are currently onboarding early companies and customers with very like white glove experience. So either way is good, whatever works for you.
Cool. Thank you for joining us. Well, a Business of Technology scheduled a call with you, by the way. So
congrats, you have a new user.
Nice.
Cool. Thank you for joining us. And well, for you, we'll see you on Slack as well. Yeah.
Yeah. Thank you, guys.
Take care, Vasek.
You too.
All right.
Cool. I think that's the one. Yeah. We keep running into race conditions every single time. It's not the first time either. I'm sure the other times I've also hosted with Nico, that, we just run into the same issue.
For clarifying to the users, basically we can like move around things inside StreamYard, which we use to make these streams. And since we're both so eager, we both click on something at the same time, and it just ends up undoing whatever the other person does. And this has been a common thing. And yeah, we need to work on our team communication skills on this. And just for anyone who's interested and wants to try out Playground, you can try it out at playground.prisma.io. And definitely give it a try if you're interested in quickly like giving Prisma a try, and you don't want to go through the setup of installing everything locally and like setting a database and everything. So it's definitely a great option for just dipping your toes into Prisma.
And also learning different workflows using Prisma Migrate as well. Yeah.
Yes, absolutely.
Cool. And our final guest of the stream is called Rida. He's the creator of a tool called Schemix, but I will let him be the one to talk all about Schemix. So we'll bring Rida on the stream. How are you?
I'm good. How are you?
I'm doing good.
Excited to be here. I can delve into Schemix a little bit, and we can get started from there.
Before we get started, for folks who don't know you, could you give a little introduction of who you are, what you do, social security numbers, maybe?
Absolutely. Credit card info, we'll throw that in there as well. My name is Rida. I am a senior reverse engineer at a company called Max Rewards. So Max Rewards is actually the reason I developed Schemix. So that'll come into play later. And I'll kind of delve onto that. But pretty much learned programming in order to do things like this, run into an issue, come up with a solution. And I think that's that's how a lot of people get their start in this space. So yeah.
Cool.
Yeah, so that's me. I'll kind of delve into Schemix here as well.
Cool.
So
yeah.
So
do you like to share your screen?
Yeah, absolutely.
As we walk through it, yeah.
For sure. Let's go here. We'll go entire screen, and we're live. All right, you guys see me?
Yes.
Awesome. So I do have a demo prepared for you guys. First, I'll just kind of explain what Schemix is. So it is open source on GitHub. It's just simply an open source library that allows you to programmatically create Prisma schemas. And a really cool side effect of this fact is that we're able to molecularize our schema by splitting it into different files. So if you've ever worked on a big Prisma schema before, they can reach thousands and thousands of lines of code. And if you're just looking for one model because you got to tweak it, it's a little easier to have everything in its own space. So that's kind of the main reason I developed Schemix, is because Max Rewards was switching over from Mongoose and MongoDB all the way over to Postgres and Prisma. So we wanted to be able to leverage all that Prisma has to offer, which is a ton, while still keeping a molecular schema. So that's when Schemix was born. So we've got a couple features in here, and I'll kind of show my demo here. But essentially, the really big ones and the things I think are really cool are mix-ins. So this adds mix-in capability, molecularization, which I've touched on a bit, and I'll show you in a moment, and then file system crawling, which kind of automatically goes through your file system and will generate your schema accordingly. So if you take a look here, I have an index.ts file, and this just sets up the
Rida, just to interrupt you a bit, maybe you could scroll in a little bit. So
I can zoom in here.
Yeah, exactly. Sorry, zoom in, not scroll in. Just
perfect. Yeah. So we have an index.ts file, and this just sets the configuration for our Prisma schema. So our data source, our generator, base path. We have other options as well in each of these. So I can also add binary target engine type, all the good stuff, extensions, what have you. And it points to my schema. So that's defined in this folder. And in this folder, I have enums, mixins, and models. And I'll kind of delve into each. So enums, we all know them. We all love them. I have a friend request status enum, which just says pending, ignored, and rejected. I just set up a little basic environment for us to take a look at. For mixins, I have a UUID mixin and a user flag mixin. And mixins are just models that allow you to allow them to get pulled into other models. And I'll kind of show you how that looks in a moment. And then in models, I have three. I have friend request model, post, and user model. So my user model looks like this. It consumes that UUID mixin I mentioned earlier. Name, email, all the good stuff. It supports relations, so we can pull in by importing friend request model, which is over here, and point to that in a relation. Same thing with posts. We have post, which looks like this. Once again, consumes that UUID mixin, just so we're not writing the same code over and over again. And friend request model, same thing. Kind of we have the same deal here. This one assumes the ID as the sender user ID and the recipient user ID, which will appear as the @ ID and an array inside in the schema. So what I can go ahead and do here is run yarn mix, which I just have to run this index.ts file. And it generates me a nice little schema.prisma. So if I look in here, I can see I have my enum that I defined inside this code. I have my post model, my user model, my friend request model, and they all display accordingly. It's all formatted. All that good stuff. Has all the relations in there, and it computes it on the fly, and it's really nice. Another way you can use Schemix, besides that, is you can do it in one big file. So you can kind of instantiate a schema like this, and then create your models, enums, and mixins as such. And what I have it doing here is just taking the schema, which contains all these models and stuff, and I can do npx ts node script generate schema, and it'll just log that into the console here. So it can be used in multiple ways. One way I would imagine it being used would be to create a web client where you can create Prisma schemas. That's an example of one use case. Or just having it kind of as that development tool, which allows you to generate schemas in a molecular fashion. So I'll kind of show an example of adding a mix in here as well.
So just to clarify, because I'm kind of trying to map mix into something that's already familiar, it seems like a concept from Alexa or something. But is mixin just a reusable snippet or?
Exactly. So if we see here, I have date time created at, updated at. Yeah. It's in, I believe, every single one. I don't know if anybody has noticed that, but it's pretty repetitive.
I
have that.
I did. I was about to ask about it.
Yes. So I left that in there as a little red herring for me. But as you can see here, I can go ahead and do wrong folder there. So I can create a new file, just call it datetime.mixin.ts. I'll do export default, create mixin. And I can just name it here, datetime mixin. And we go and we'll grab that little snippet here, just like that. We'll say datetime mixin. We'll paste that in here. We'll make it a little prettier. And we can just save it. And so what I can do now is take this and just say .mixin, datetime mixin. And just like that, I have added a mixin. If I go ahead and save that and then run my command again, we'll go to the user model and just confirm that it's there, and it is. So we've successfully added a mix into this, and we would go ahead and do that for every single one we want to consume. The really neat thing about this is we don't just have to statically define things. I have a user flags.json file in here, which has a bunch of flags that I want to add to a model. So I've created a user flags mixin like this. And what this does is it takes that array, it iterates over the mixin and adds each property as a Boolean field to the model. So if I go ahead and consume this flags mixin like that, and then run this, and we take a look inside the schema, you'll notice that we have that array now as fields in our schema. So if we have really repetitive fields, we can go ahead and kind of shorten that, put it in a file, put it in an array, however we want to have it stored, and then iterate over that. We can also compute them on the fly as well. So it really opens up a lot of possibilities for generating your schema.
Really cool, really cool. I also noticed that it respects the order that you defined in the particular models and mixins.
It didn't for a little bit, but we had an issue opened up on the GitHub and somebody raised concerns, so I went ahead and fixed that for them. Yeah.
Cool. And just does one have to follow the conventions of adding the model.ts suffix to a particular model?
No.
Or
you don't. As long as it's in the models folder, you're good to go. You can also add subdirectories as well. So if I had a bunch of models that were all pertaining to users, I could create a users folder and then put submodel in here. And I can omit the .model part as well. That's just something I do myself.
Cool. One other question is, how does the type safety work when defining Schemix? Or where are the types inferred from, by the way?
Yes. So for the types are defined as options. So when I'm creating a string, for example, here, and I have all these options to kind of work with. These are all specifically defined in the Schemix library. Each type, for example, string, has its own set of options that can be added. I'm currently working on adding enum support. So currently enums don't get defined as inferred as a type. So I don't have a type that would say pending, ignored, rejected, but that is a possibility. I do have a prototype of that working, and I think it's really cool. But still working on getting the types. But you do have all the types good for the options, all that good stuff. So yeah.
That's really cool.
Thanks, guys.
We have a question from the chat. Or before we jump into the chat, do you have any questions, Tasin?
Again, you kind of asked a lot of the questions I had. So, but yeah, I just actually wanted to mention that I think it's really nice that you can modularize, sorry, second language, modularize your schema like this, because I've been playing around a lot with Nest.js recently. And one of the things that people who use Nest.js and Prisma frequently like get annoyed by is the fact that the schema is by default, like without using like some other libraries, well, like Schemix, of course, but like by default, you have to kind of put it in one big place and it becomes massive. And it's just not very idiomatic to the way Nest.js does things, where you kind of you have these modules where you put all the relevant business logic for that module, including the sort of data modeling, ideally. So having something like this is really useful in situations where you want to split everything up for convenience or just to follow certain conventions or whatever. So I can totally imagine a lot of people from the Nest.js community finding value in this library, among other like use cases. So
awesome. Yeah. No, totally.
Wild idea that I had while you were speaking, Tasin. What if someone in the community, could be you, Tasin, could be Rida, created a tool that follows Nest.js's conventions to generate a Prisma schema?
That would be pretty.
That makes sense.
And there's a lot of ways that this can be expanded upon and kind of worked from as a base. It's really exciting to see it used in other people's projects as well. So yeah, loving this all the way.
Pretty cool. And we have a couple of questions from the chat. There's one from Business of Technology. And do you have a training course available for this?
For Schemix?
Yeah.
I guess so.
I might need one. I would be super happy to write more comprehensive documentation on it, so that other people can pick it up more easily. I'm also getting into content creation myself, so I'd be happy to throw up some tutorials as well. Message me, at me on Twitter, and I will get back to you on that, because that sounds like something that could go a long way. Absolutely.
Cool.
And for context, oh, sorry. Yeah.
Just go ahead.
Yeah, so this one was, I think, in the context of mixins, where it kind of works like a bit like inheritance.
Yes.
Which is also like a feature that Prisma currently doesn't support. So yeah, it's definitely like a very good way to get some of those inheritance capabilities, or just avoid duplicating a lot of the same repetitive fields. So
yeah, totally.
A noob question from me is mixin like an alternative to inheritance, or are they different paradigms around the same problem?
I believe they are, but I might be completely misusing the term. But I believe they are. I do have an actual inheritance functionality in here as well. So if I go to my generate schema file as well, I can actually do const some other model equals user model dot extend, and then rename this to some other model, and then actually add more properties. And this would completely be a new model. It's not something, I don't think I have this listed in the doc. It's something that's used internally. Once again, need some more comprehensive documentation for that. But I think it's a really useful feature, but it can only be utilized in the programmatic sense at the moment. So yeah,
pretty cool. And I believe inheritance is something we haven't added to Prisma yet, or we have been exploring. Yeah, it's pretty cool that Schemix already offers that. Yeah.
Any other questions for me?
I think, yeah, there's one on your Twitter handle. Yeah.
I'll just add that in real quick.
Cool. I think the question was related on usage. Can you use it in any kind of project? Meaning, for example, Next.js, Vue, I don't know, Node.js,
yes.
Express. Yeah.
Absolutely. Cool. So any environment that runs JavaScript, you can do it. You can kind of think of it more as a development tool, and I do want to build out an official CLI for it, just so you don't have to do something like what I've done here, which is just run ts node on the index file. But the gist is, if you run this file in a node environment and it has the proper configuration I have set here, you are able to generate this schema.prisma file for any environment. So I've actually used this in a Rust project. So I had my own little section for Schemix and Prisma, and using a third-party client, I was able to use it in a Rust project. So yeah, it works for virtually everything. Any environment that can run JavaScript, you are good to go.
Cool. Thank you for all that. Well, I learned a lot, that's for sure. Yeah.
Yeah, that was really awesome. Thank you, Rida.
Thank you so much, guys. This was an absolute pleasure to do.
Awesome. So again, thank you for joining us. I believe we will move into the next section. We've shared your contact in the chat in case anyone would like to reach out to you. Now we'll move on to the next section. Thanks for joining. We'll hope to see you soon with another tool. Yeah.
Thank you.
Cool. Another race condition.
Oops. Okay.
Cool. That was a pretty interesting stream. I've learned a lot, that's for sure.
Yeah,
From
like my
fact
neurons are
and-
just firing so much. Like I can hear the fan inside my brain, like, ramping up. Oh.
Cool. For those who joined us live, thank you for joining us. If you have any questions, feel free to post it on either our GitHub discussions, in our public Slack, at us at Twitter as well, either Tasin, the Prisma account, or I. We'd be happy to answer your question. And we'll see you on the next episode.
Bye, everyone.
Bye.